This clip going through several different aspects of organic chemistry across the 2 years of the A-level course. Questions about unsaturated aldehydes and alcohols, and it gives you a structure here of 3-methyl-but-2-NL. So looking at that structure, you can see there's two functional groups. There's a CC double bond and there's an aldehyde. So you need to be careful of that when you're answering the question in its different parts. First thing it says is it's reacted with hydrogen bromide, so hydrogen bromide can behave as an electrophile towards the carbon-carbon double bond. It asks you to outline the reaction mechanism, so that's going to be electrophilic addition, for the formation of one of the organic products. That means it doesn't matter which one you choose. But the important thing is to include the curly arrows and relevant dipoles in the correct way. So if we look at drawing out the structure, I would suggest copying it out as the question gives it, because then it's designed to help you. So we've put that in there, and then thinking about our curly arrows and relevant dipoles, we can put in the hydrogen bromide, but put the delta plus and delta minus in the correct place, and also the curly arrows beginning and ending in the appropriate manner. A little bit of space to the right of that allows us to put in one of the intermediates. It doesn't matter which carbocation you choose, however, you need to make sure that your bond connections are appropriate, such as the CH3 there and the CHO there, just to name two. Finally, you put the structure in that matches that particular carbocation. Then it asks you to explain why one of the organic products forms in a much greater quantity. So this is coming on to Markovnikov's rule, which requires you to talk about which carbocation is formed and also the relative carbocation stability. So starting off by saying you get a tertiary carbocation formed with more carbon atoms attached to the positively charged carbon. And therefore that's going to be more stable, so that's going to lead to the major product. The alternative is a secondary carbocation, so you make a comparative statement about which is more likely to lead to the major product in greater amounts. Next part of the question introduces two new compounds, an alcohol with a CH2OH primary alcohol called geraniol. It also happens to have two double bonds in it, carbon-carbon double bonds, that is, alkene bonds. And then you've got citronellal, which has an alkene bond in it, plus it's also got a CHO, the aldehyde group at one end. So it asks you to describe how the observations from a chemical test, so what they mean by chemical test is it doesn't involve spectroscopy or chromatography. So there's two possible correct answers here, one of which is 2,4-DNP, and for that you need to say that the citronellal with the CHO will form a red or orange precipitate. The second is Tollens reagents, that's the other option, and again citronellal having an aldehyde group will form a silver mirror in this particular case. The next question asks you about the molecular formula, so be careful here because the molecular formula mustn't have any details of the functional groups. So this is strictly just C10H18O, nothing else, no OH, no CHO, nothing less like that. Then you explain why geraniol and citronellal have structural isomers, or are structural isomers of one another. It's essentially the definition, same molecular formula, different structural formulae. Explaining the term stereoisomerism requires a slight shift in what you're saying, so it's the same structural formula, but different arrangement of atoms in space. So the final, more challenging part of the question has an unstructured feel to it. So it gives you some instructions, and it's worth taking a moment to have a think about what they say. Types of stereoisomerism, plural, suggest more than one type of stereoisomerism. So don't just go for the obvious one, there's also the possibility of others as well. 2 bullet points give it just instructions to follow, and the carbon atoms are numbered for a reason, so you use those in your answer. So geraniol has EZ isomerism in the carbon-carbon double bond at carbon 2. Not over here, because over here you've got two CH3 groups coming off, so that's not EZ isomerism. Citronellal has optical isomerism at carbon number 3. So be careful to choose carbon 2 when you draw out the stereoisomer for geraniol. It gives you the E isomer already, so push in the Z isomer. For citronellal, quite straightforward. You draw out carbon number 3 as a chiral carbon, like so. Push in a dotted line to represent a mirror. Then you can put in 2 mirror images with the groups orientated appropriately. Okay, so hopefully this has been a useful look at this type of question. And thank you for listening. Until next time, see you soon.